Welcome to the Certified Hospital and Healthcare Fire Safety Professional course, presented by CDGTraining. This course is designed to protect patients, healthcare workers, critical medical equipment, and healthcare facilities through effective fire prevention and emergency response. Welcome to the course. Fire safety is one of the most critical responsibilities in healthcare environments. This course offers practical knowledge and professional skills to help healthcare professionals prevent incidents and respond effectively to emergencies. Comprehensive protection is at the heart of this training, ensuring safety through structured fire prevention and emergency response strategies. Fire safety in healthcare facilities is a unique challenge due to the presence of patients who may not be easily evacuated. Even minor incidents can have significant consequences, making fire safety a critical priority. Effective management helps organizations maintain safety and minimize risks. Hospitals face numerous fire risks that require specialized prevention and risk management strategies. From oxygen systems to electrical equipment and laboratories, understanding these specific risks is essential for effective safety programs. Global fire safety standards and regulations are crucial for maintaining safety in healthcare facilities. Organizations like NFPA, WHO, and Joint Commission International provide comprehensive guidelines to ensure patient safety and operational resilience. A fire safety management system is essential for preventing fires, managing risks, and responding to emergencies. It forms the backbone of a resilient healthcare safety program, focusing on prevention, compliance, training, and response. Fire safety is a shared responsibility among all healthcare workers. Safe work practices, hazard reporting, and emergency preparedness are key to preventing incidents and ensuring a safe environment for everyone. In a fire emergency, protecting patients is the highest priority. Healthcare facilities must be prepared for the safe movement of all patient populations, each with unique evacuation challenges. Hospitals depend on critical infrastructure that must remain operational during emergencies. Systems like electrical, emergency generators, and communication networks are vital for patient care and safety. Fire risk assessment is crucial for identifying hazards, evaluating risks, and implementing controls. Regular assessments support proactive prevention and compliance across healthcare facilities. Preparedness ensures that healthcare facilities can respond quickly and effectively when emergencies occur. Defining roles, communication procedures, evacuation methods, and regular drills are essential for effective emergency response planning. This course covers operational, technical, regulatory, and emergency management perspectives to build comprehensive fire safety expertise. From fire hazards to compliance and future technologies, you'll gain the knowledge needed to ensure safety in healthcare environments. The most effective fire safety programs are built on a strong organizational culture. Leadership commitment, active participation, and continuous improvement are key to integrating fire safety into daily healthcare operations. Hospital and healthcare fire safety is a specialized discipline focused on protecting patients, healthcare workers, visitors, critical medical equipment, and healthcare infrastructure from fire-related incidents. In this CDO training chapter, learners will explore fire science fundamentals, fire risks, fire prevention principles, hospital safety culture, and the critical components of an effective healthcare fire safety program. Fire safety in healthcare extends beyond protecting buildings from fire damage. It involves safeguarding vulnerable patients, maintaining continuity of medical services, protecting critical equipment, and ensuring rapid emergency response capabilities. Fire is a rapid chemical reaction that occurs when fuel, heat, and oxygen combine in sufficient quantities. This reaction produces heat, light, smoke, and combustion products. Understanding how fire starts is essential for preventing incidents in healthcare environments. Fire is not simply a hazard, it is a predictable chemical process that can be controlled when its components are understood and managed. The fire triangle is one of the most important concepts in fire safety. The three elements required for combustion are fuel, heat, and oxygen. Removing any one of these elements will prevent or extinguish a fire. Healthcare fire programs focus on controlling all factors to prevent ignition. Fuel sources in healthcare facilities are diverse and present throughout clinical and non-clinical areas. Identifying and managing these sources is a critical component of fire risk assessment. Electrical equipment or improper use can create ignition sources. Routine inspections help identify potential hazards before incidents occur. Hospitals frequently use oxygen therapy and medical gas systems to support patient care. Although oxygen itself does not burn, it accelerates combustion and can cause fires to spread more rapidly in oxygen-enriched environments. Modern fire science expands the fire triangle into the fire tetrahedron. In addition to fuel, heat, and oxygen, fire requires a chemical chain reaction to sustain combustion. Many fire suppression methods work by interrupting this chain reaction. Healthcare facilities operate continuously and contain large numbers of vulnerable occupants. These conditions make fire emergencies particularly challenging to manage. Healthcare facilities face a wide range of fire hazards across both clinical and non-clinical environments. Recognizing these hazards is the first step toward effective prevention. Healthcare fires can result in injuries, fatalities, property damage, service disruption, regulatory penalties, and reputational harm. Even small fires can interrupt critical patient care services. The consequences often extend far beyond the immediate fire event. Fire prevention focuses on eliminating hazards before incidents occur. Prevention remains the most effective form of protection in any healthcare environment. Healthcare facilities use multiple layers of protection to reduce fire risk and minimize consequences. A layered approach improves resilience and ensures that no single point of failure can result in catastrophic outcomes. Fire safety responsibilities are shared across all levels of the organization. CDGTraining emphasizes that fire safety becomes most effective when every employee actively participates in prevention efforts. A strong safety culture encourages employees to prioritize safety in daily activities. Culture influences behavior and performance. Organizations with strong safety cultures consistently demonstrate better fire prevention outcomes. An example of a fire originating from faulty electrical equipment occurred in a storage area. This incident underscores the importance of regular equipment inspections and preventive maintenance to prevent similar occurrences. Healthcare facilities face diverse fire hazards across clinical and non-clinical environments. Electrical systems and oxygen-related risks often represent the most significant concerns. Regular assessments help organizations prioritize mitigation efforts. Successful fire prevention programs rely on multiple contributing factors. Training, maintenance, and proactive hazard identification consistently rank among the most effective fire risk reduction measures. Continuous monitoring suggests improvement. Healthcare fire safety will evolve through the adoption of intelligent detection systems, predictive maintenance technologies, connected sensors, and automated monitoring platforms. These improvements help organizations identify risks earlier and respond more effectively. Hospital fire safety combines fire science, risk management, prevention strategies, emergency preparedness, and organizational culture. Healthcare facilities face unique challenges due to vulnerable patient populations, complex infrastructure, and continuous operations. Healthcare facilities contain numerous fire hazards that require careful management and continuous monitoring. Understanding these hazards helps organizations implement effective prevention and protection measures. A fire hazard is any condition, material, or activity that increases the likelihood of a fire or contributes to its severity. Healthcare facilities contain both clinical and non-clinical fire hazards that require specialized control measures tailored to each environment. Recognizing risks before they escalate is the first step in protecting patients and staff. Electrical systems are among the leading causes of fires in healthcare facilities. Faulty wiring, overloaded circuits, damaged equipment, and improper electrical installations can all create dangerous ignition sources. Regular inspection and maintenance of all electrical systems are essential to preventing fire incidents in healthcare settings. Healthcare environments rely on numerous electrical devices operating simultaneously, creating significant electrical load demands that can exceed safe circuit capacities. Organizations should monitor power usage, conduct regular load assessments, and avoid unsafe electrical connections throughout all care areas. Medical devices can present fire risks if they malfunction, overheat, or are improperly maintained. Preventive maintenance programs help identify potential failures before they become hazardous, directly supporting patient protection. Medical gas systems support critical patient care activities but can significantly increase fire risks when improperly managed. Oxygen, nitrous oxide, and other gases require strict storage, handling, and maintenance procedures to ensure safe healthcare operations. Oxygen-enriched environments can dramatically increase fire intensity and spread. Even a modest increase in oxygen concentration can significantly accelerate combustion and make fires much harder to control. Oxygen safety procedures are necessary in all areas where supplemental oxygen is used. Improperly stored or damaged gas cylinders can create serious safety hazards in healthcare facilities. A cylinder that is knocked over, damaged, or has a compromised valve can become a dangerous projectile or release flammable or oxidizing gases. Laboratories may contain flammable liquids, reactive chemicals, open flames, and specialized equipment that create unique fire hazard profiles. Chemical compatibility, ventilation, and storage practices are critical to laboratory fire prevention. Many healthcare facilities use alcohol-based products, cleaning chemicals, solvents, and laboratory reagents that are highly flammable. Improper storage or handling can significantly increase fire risks once clinical and support areas are compromised. Hospital kitchens contain cooking appliances, grease accumulation, open heat sources, and electrical equipment that represent some of the most fire-prone environments in any healthcare setting. Cooking-related fires are among the most common in many facilities. Laundry operations generate significant heat and process large quantities of combustible materials such as linens and clothing. The combination of heat, combustible textiles, and mechanical equipment creates a challenging fire risk environment. Storage areas often contain combustible materials including paper products, packaging materials, textiles, and medical supplies. These areas can accumulate significant fire load and may contribute to fire spread if not properly managed. Maintenance activities such as welding, cutting, soldering, and grinding can generate sparks and ignition sources that pose significant fire risks in healthcare environments. CDGTraining emphasizes that uncontrolled maintenance activities are a common source of preventable fires. Smoking materials remain a potential ignition source in some healthcare environments. Organizations must enforce strict policies and actively monitor for unauthorized ignition threats throughout the facility. A healthcare facility experienced a fire incident in a laundry processing area. The root causes were identified as overheating equipment and significant lint accumulation in dryer venting systems, both preventable conditions. Early detection systems and trained staff response prevented this incident from escalating into a major fire affecting patient care areas. Healthcare organizations face a wide range of fire hazards across both clinical and support service areas. Electrical systems and medical gas environments often represent the highest areas of concern. Fire incidents result from a combination of technical failures, unsafe conditions, and human factors. Organizations that address these proactively can significantly reduce overall risk. Effective hazard identification involves regular inspections, employee reporting programs, maintenance reviews, and formal risk assessments. Organizations should encourage active participation from all departments. Early detection prevents escalation. Healthcare facilities contain diverse fire hazards that require systematic identification, evaluation, and control. Electrical systems, medical gases, laboratories, kitchens, storage areas, laundry operations, and maintenance activities all present potential risks that must be actively managed. Fire risk assessment is a crucial part of healthcare safety management. It helps organizations identify hazards, evaluate risks, prioritize corrective actions, and prevent fire incidents before they occur. In this CDG training chapter, learners will explore fire risk assessment methodologies, hazard identification techniques, risk evaluation tools, healthcare inspection processes, documentation strategies, and mitigation planning approaches. A fire risk assessment is a systematic process used to identify fire hazards, evaluate associated risks, and determine appropriate control measures. The core purpose is to reduce the likelihood of fire incidents and minimize their potential consequences. Prevention is more effective than emergency response. This structured approach ensures that healthcare organizations address fire safety systematically and consistently across all areas of their facilities. Healthcare facilities house patients who may be unable to self-evacuate, making fire prevention critically important to protect lives. Life-sustaining equipment and complex infrastructure require continuous protection from fire threats that could disrupt care delivery. Fire risk assessments help organizations identify weaknesses before incidents occur and support informed decision-making at all levels. Prevention is more effective than emergency response. Assessments shift the focus from reaction to anticipation and control. The primary objectives are to identify hazards, evaluate risk levels, determine necessary controls, and improve overall fire safety performance. Assessments also support compliance with regulations and accreditation requirements. Clear objectives improve assessment quality and ensure that resources are directed where they are needed most. Hazard identification is the process of recognizing conditions that could contribute to a fire event. It forms the foundation of every effective risk assessment and must be conducted thoroughly and systematically. Accurate hazard identification ensures that no significant risk is overlooked during the assessment process. Common examples include faulty or overloaded wiring, oxygen-rich environments, combustible material storage, blocked emergency exits, malfunctioning equipment, and inadequate housekeeping. Assessments should evaluate electrical systems, medical gas installations, laboratories, kitchens, storage areas, maintenance activities, and emergency systems. Each area presents unique fire risks that require specific controls. Comprehensive evaluations of all operational areas improve safety outcomes and reduce the likelihood of fire incidents. Likelihood refers to the probability that a fire incident could occur given the current conditions, practices, and environment within a healthcare facility. Understanding probability helps organizations prioritize risks and direct resources toward the most significant threats. Factors affecting likelihood include equipment condition, employee behavior, and environmental conditions. Consequences refer to the potential impact of a fire event. Severity influences how risks are prioritized and what level of corrective action is required. Key areas include patient safety, business interruption, property damage, regulatory impact, and reputational harm. Risk matrices combine likelihood and consequence ratings to determine overall risk levels. This approach helps organizations prioritize corrective actions and allocate resources effectively. Risk matrices simplify decision-making by providing a consistent, visual framework for comparing and ranking identified hazards across all areas of a healthcare facility. Risks are commonly categorized as low, medium, high, or critical. Higher risk findings require immediate attention, while lower risk issues may be addressed through routine improvement activities. Consistent ratings support effective management. Inspections provide valuable information for fire risk assessments. Regular inspections identify emerging hazards before they escalate into serious incidents. Inspectors evaluate equipment condition, emergency exits, storage practices, and suppression systems. Employees often possess valuable knowledge about workplace hazards and operational challenges. Staff involvement strengthens assessment quality and builds a culture of shared safety responsibility. Interviews help gauge how staff understand fire risks and their roles in day-to-day operations. Conversations reveal whether established safety protocols are being followed consistently in day-to-day operations. Historical information helps organizations identify recurring issues and prioritize preventive actions. Past incidents, near misses, and audit findings provide important insights that cannot be obtained through inspection alone. Learning from history reduces future risks. Assessment findings should be documented clearly and accurately. CDGTraining emphasizes that thorough documentation supports accountability and continuous improvement across the organization. Key areas include identified hazards, risk ratings, corrective actions, responsible personnel, and completion timelines. Risk mitigation involves implementing controls that eliminate or reduce identified hazards. Effective mitigation strengthens organizational resilience and reduces the likelihood of future fire incidents. Key areas include equipment repairs, staff training, engineering improvements, and policy updates. In this case study, hazards identified included overloaded electrical outlets near patient beds, obstructed access pathways between equipment, and inadequate oxygen cylinder storage practices. Corrective actions taken included electrical system upgrades and outlet management, improved housekeeping and pathway clearance procedures, and enhanced staff training on oxygen storage protocols. The assessment significantly reduced operational risks and improved safety compliance across the ICU, demonstrating the power of proactive fire risk management. Healthcare fire risk assessments cover multiple operational and technical areas. Electrical systems and medical gas environments frequently receive significant attention due to their potential consequences. Each area presents unique risks requiring specific, targeted control measures. Many high-risk findings result from preventable operational deficiencies. Maintenance programs, training initiatives, and regular inspections help reduce the frequency of these issues. Poor equipment maintenance consistently ranks as the most common high-risk finding, underscoring the critical importance of successful preventive maintenance programs in healthcare facilities. Risk assessment should not be treated as a one-time activity. Healthcare environments change constantly, and continuous assessment supports ongoing protection for patients, staff, and facilities. Assess, document, mitigate, and review are essential components of a continuous assessment cycle. Fire risk assessment is a systematic process that helps healthcare organizations identify hazards, evaluate risks, prioritize actions, and strengthen fire safety performance. Effective assessments encompass methodologies, staff engagement, historical data, documentation, and mitigation planning. Key takeaway: effective fire risk assessment methodologies help organizations to identify hazards early, prioritize resources wisely, and implement controls that reduce the likelihood and consequences of fire incidents. Fire prevention is crucial for protecting people and facilities from fire-related incidents. This chapter explores strategies and controls to maintain a proactive fire prevention culture. Understanding fire prevention involves identifying hazards, eliminating them before ignition, and adopting a proactive strategy to prevent incidents. Healthcare facilities must prioritize fire prevention to protect vulnerable populations and ensure safety during emergencies. A comprehensive fire prevention program includes inspections, maintenance, training, housekeeping, hazard reporting, and compliance monitoring. Preventive maintenance involves regular inspections and addressing deficiencies to enhance fire safety. Electrical safety maintenance is crucial to prevent hazards from damaged wiring and equipment. Housekeeping reduces fire risks by managing combustible materials and maintaining organized spaces. Managing combustible materials involves safe storage and reducing fire risks from paper, packaging, textiles, and flammable substances. Safe storage practices ensure emergency access and compliance with safety policies. Controlling ignition sources like electrical faults, open flames, and sparks reduces fire risks. Hot work activities pose fire risks and require careful planning and supervision to prevent incidents. Hot work permit systems ensure safety by evaluating and controlling risks before work begins. Smoking control policies reduce ignition risks and enhance safety in healthcare facilities. Effective hazard reporting programs strengthen prevention efforts by addressing unsafe conditions promptly. Building a fire prevention culture involves regular awareness campaigns, training, and leadership engagement. A case study demonstrates the value of preventive maintenance in avoiding potential electrical fires. Fire prevention programs require a balance of technical controls, operational procedures, and people engagement. Understanding the causes of preventable fire incidents helps in addressing them effectively through structured programs. Continuous improvement in fire prevention involves analyzing trends, conducting audits, and implementing changes. Fire prevention strategies and controls help healthcare organizations eliminate hazards and build a prevention-first culture. Fire detection and alarm systems are crucial in healthcare settings, providing early warnings to protect patients, staff, and infrastructure. This chapter explores various components and best practices for effective fire detection. Early fire detection is vital in reducing the consequences of fire incidents. It enables rapid action and highlights the critical nature of time and emergency management. Fire detection systems serve as the first line of defense, generating alerts and improving emergency responses to protect lives and property. A fire detection system comprises detectors, control panels, notification devices, and more, each playing a vital role in overall system performance and reliability. Smoke detectors are essential in healthcare, providing early warnings of fire conditions, which is critical for patient safety. Different smoke detectors, like photoelectric and ionization, are used for various fire types, ensuring optimal performance in healthcare environments. Heat detectors activate when temperatures exceed limits, complementing smoke detectors and providing reliable performance in harsh conditions. Fixed temperature heat detectors activate at specific thresholds, providing reliable protection in challenging environments. Rate of rise heat detectors respond to rapid temperature changes, offering earlier detection and faster emergency responses. Fire alarm control panels are central to monitoring and managing fire detection systems, coordinating signals and responses throughout a facility. Notification appliances alert building occupants during emergencies, using audible alarms, visual strobes, and voice communication to ensure safety. Voice evacuation systems provide clear instructions during emergencies, improving outcomes by guiding occupants effectively. Fire alarm monitoring systems ensure rapid response by transmitting signals to central stations, enhancing overall protection. Integration with building safety systems enhances emergency preparedness, coordinating alarms with elevators, ventilation, and access controls. Regular inspection and testing of fire detection systems ensure reliability and support emergency preparedness. A case study demonstrates how early detection prevented a major hospital fire, showcasing the importance of strategic fire detection equipment placement. Hospital fire alarm systems combine multiple technologies, with smoke detectors being the largest component, ensuring comprehensive protection. Effective fire detection systems offer numerous benefits, including early warnings, faster responses, and improved safety, reducing property damage and enhancing compliance. Emerging detection technologies like AI and connected sensors enhance fire protection capabilities, improving detection accuracy and response times. Chapter Summary. Fire detection systems are vital for healthcare safety, integrating smoke and heat detectors, control panels, notification devices, and monitoring for comprehensive protection. Fire suppression systems are crucial in healthcare settings to prevent significant harm from fires. This chapter covers various systems like fire extinguishers, sprinklers, and hydrants, along with their maintenance and inspection requirements. Fire suppression involves methods to control or extinguish fires by removing heat, reducing oxygen, interrupting reactions, or separating fuel. Each method plays a vital role in minimizing damage and ensuring safety. In healthcare, suppression systems ensure continuous operations by quickly controlling incidents, reducing risks, and protecting patients and staff. Rapid suppression is essential for maintaining safety and operational continuity. Healthcare facilities use various suppression systems like extinguishers, sprinklers, and standpipes to address diverse fire risks. Each system offers unique benefits and protection levels. Portable fire extinguishers are the first line of defense in emergencies. Proper placement and training are essential to ensure they are accessible and used effectively. Different fire extinguishers are designed for specific fire types. Understanding these classifications is critical for effective suppression and safety. Proper use of fire extinguishers involves the pass method: pull, aim, squeeze, and sweep. Safety and training are paramount when using extinguishers. Automatic sprinkler systems are highly effective in controlling fires early. They operate without human intervention, providing continuous protection across healthcare facilities. Sprinkler systems activate when heat triggers the head, leading to water discharge and alarm activation. This targeted approach minimizes water damage while effectively controlling fires. Wet pipe sprinkler systems are always ready, providing rapid response and high reliability. They are the most common type in healthcare facilities. Dry pipe and pre-action systems prevent accidental water discharge, protecting sensitive equipment. They are valuable in environments where water damage could be critical. Standpipe systems provide water supply connections throughout large buildings, aiding emergency responders. They are classified into 3 classes based on their use and connection types. Fire hydrant systems ensure water access for firefighting operations. Regular maintenance and coordination with fire departments are crucial for effective use. Special suppression systems like clean agent and gaseous suppression are designed for specific environments. They protect sensitive equipment and areas with unique fire risks. Suppression systems in critical healthcare areas are tailored to specific needs, ensuring safety and continuity during emergencies. Each area requires a unique approach based on its function and risks. A real-world case study highlights the effectiveness of sprinkler systems in controlling a hospital fire. Key lessons emphasize the importance of automatic suppression systems in healthcare. A pie chart illustrates the distribution of fire suppression equipment in healthcare facilities, highlighting the prevalence of automatic sprinkler systems and portable extinguishers. Fire suppression systems offer numerous benefits, including reduced fire spread, improved safety, and faster emergency control. These systems are vital for business continuity and regulatory compliance. Regular inspection and maintenance ensure fire suppression systems remain functional and reliable. Key tasks include verifying equipment condition, confirming water supply, and checking valve status. The chapter summary highlights the critical role of fire suppression systems in healthcare, emphasizing the importance of proper maintenance and training for effective fire response. Medical gases are crucial for patient care but pose significant fire and safety risks if not managed properly. This chapter explores the importance of safety in handling medical gases, focusing on oxygen. Medical gases support vital healthcare functions. Oxygen is essential for life support, while medical air aids in respiratory therapy. Nitrous oxide is used in surgeries and carbon dioxide in diagnostics. Proper management ensures safety. Oxygen is vital for life-saving treatments but poses hidden risks. It supports combustion, making safety practices essential in healthcare environments. Oxygen-enriched atmospheres can lead to faster ignition, aggressive fire spread, and increased severity. Understanding these risks is crucial for healthcare personnel. Oxygen accelerates combustion, lowers ignition thresholds, and increases fire growth rates. Understanding these effects is vital for fire safety. Proper design and management of medical gas storage systems reduce fire and explosion risks while ensuring patient care delivery. Oxygen cylinders pose high pressure risks, potential physical damage, and heat exposure hazards. Safe management is essential to prevent accidents. Safe storage practices, including securing cylinders upright, clear labeling, separation from ignition sources, and proper ventilation, are vital for compliance and safety. Medical gas pipeline systems ensure safe delivery of gases throughout healthcare facilities. Maintaining system integrity and pressure management is essential for safety. Detecting oxygen leaks is crucial for safety. Routine inspections, continuous monitoring, and preventive maintenance help identify and address potential leaks. Oxygen-related fires can result from smoking materials, electrical faults, open flames, static electricity, and improper equipment use. Prevention is key. Regular inspections, identifying ignition sources, and an integrated safety approach are essential for electrical safety around oxygen systems. Healthcare workers must follow procedures to avoid ignition sources, verify equipment operation, maintain awareness, and adhere to protocols for oxygen safety during patient care. Emergency procedures for oxygen incidents include detecting and alerting, isolating the source, evacuating if necessary, and reporting and investigating the incident. All staff share responsibility for medical gas safety. Key responsibilities include hazard reporting, equipment inspections, safe handling, protocol compliance, and training participation. A case study highlights the importance of safety training and protocols in preventing oxygen-enriched environment incidents and improving outcomes. Medical gas safety risks include cylinder handling, pipeline system management, equipment failures, human error, and maintenance deficiencies. Addressing these areas is crucial. Key controls for oxygen safety include staff training, equipment maintenance, leak detection programs, safe storage practices, hazard inspections, and emergency preparedness. Future developments in medical gas safety include connected sensors, predictive maintenance, and automated alarm systems, enhancing proactive safety management. Medical gas safety is critical for fire prevention and risk management. Key areas include storage and handling, monitoring and maintenance, training and awareness, and emergency preparedness. Emergency preparedness enables healthcare facilities to respond effectively to fire incidents while protecting patients, staff, visitors, and critical healthcare operations. In this CDG training chapter, learners will explore emergency response plans, incident command systems, communication procedures, emergency room roles, preparedness exercises, and strategies for managing fire emergencies in healthcare environments. Prepared organizations can minimize confusion, reduce response times, and improve outcomes during fire incidents. Preparation is the foundation of resilience. Key components include planning, organizing, training, and equipping. Each element plays a crucial role in ensuring a coordinated and effective response. Healthcare facilities operate continuously and often care for patients who cannot evacuate independently. This creates unique and complex emergency response demands unlike any other environment. A well-developed fire emergency plan ensures coordinated actions during emergencies and reduces risks to patient safety. Structured planning improves response effectiveness across all departments and shifts. Emergency response plans provide clear guidance during emergencies. Structured planning improves coordination across all levels of the organization. Key components include roles and responsibilities, communication procedures, evacuation strategies, emergency contacts, and resource requirements. The primary objectives of emergency response are to protect life, control the incident, maintain essential services, and minimize damage. Healthcare organizations should prioritize patient safety while coordinating emergency actions. Clear objectives support effective decision-making under pressure. The Incident Command System is a standardized management structure used to coordinate emergency response activities across organizations and agencies. It was developed to address the challenges of managing complex, multi-agency incidents. ICS helps establish clear authority, communication pathways, and operational responsibilities during emergencies. Each ICS role supports specific response functions. Clearly defined responsibilities reduce confusion during emergencies and ensure all critical functions are covered. Key roles include the Incident Commander, Operations Section, Planning Section, Logistics Section, and Finance Administration. Fire emergency procedures outline the actions personnel should take when a fire is discovered or suspected. Standardized procedures support rapid, coordinated response across all departments. Key steps include alarm activation, notification, evacuation actions, and emergency coordination. Many healthcare facilities use the RACE principle during fire emergencies. This simple framework helps personnel respond systematically during fire incidents. R stands for rescue, A for alarm, C for confine, and E for extinguish or evacuate. Communication systems play a vital role during emergencies. Timely communication improves situational awareness and supports coordinated response across the entire facility. Key systems include fire alarms, public address systems, mobile notifications, two-way radios, and emergency messaging platforms. Internal communication ensures that staff understand evolving conditions and response expectations throughout an emergency event. Without clear internal messaging, even well-trained teams can become disorganized. Communication should be accurate, consistent, and timely. Healthcare facilities should establish relationships with local fire departments, emergency medical services, law enforcement agencies, and utility providers. Coordination improves response efficiency during emergencies, and partnerships strengthen overall preparedness. Emergency response requires access to personnel, equipment, transportation resources, communication tools, and medical supplies. Organizations should identify critical resources in advance to ensure their availability. Preparedness supports operational continuity. Recovery planning helps organizations restore normal operations after a fire incident. CDGTraining emphasizes that recovery planning should begin before emergencies occur, not after. Key steps include immediate response, patient care continuity, infrastructure restoration, equipment replacement, and stakeholder communication. Exercises help evaluate emergency plans and improve organizational readiness. Practice improves performance and reveals gaps that cannot be identified through planning alone. Types of exercises include tabletop exercises, functional drills, evacuation simulations, and full-scale exercises. A healthcare facility conducted a large-scale fire emergency exercise involving clinical staff, facility personnel, and local firefighters. The exercise was designed to test the facility's emergency response plan under realistic conditions. Subsequent drills demonstrated significant improvements in response coordination and preparedness. Preparedness programs combine planning, training, communication, exercises, and resource management activities. Emergency planning and workforce readiness are among the most important contributors to successful response efforts. Several factors influence response effectiveness. Organizations that invest in training, planning, and communication generally achieve stronger emergency preparedness outcomes. Staff training and clear communication consistently rank as the top drivers of successful emergency response in healthcare settings. Healthcare organizations are increasingly adopting advanced technologies to support preparedness and emergency management. Technology continues enhancing resilience across all aspects of emergency response. Key trends include digital command centers, predictive analytics, mobile communication platforms, and intelligent monitoring systems. Emergency preparedness and fire response planning help healthcare organizations protect lives, maintain essential services, and manage incidents effectively. Successful programs combine planning, communication, training, emergency exercises, leadership, and continuous improvement. As taught in CDGTraining's framework, preparedness is not a single document or exercise. It's an ongoing organizational commitment that strengthens resilience and improves emergency outcomes. Patient evacuation is a critical aspect of healthcare fire safety, requiring careful planning and execution. This chapter will explore essential evacuation principles, priorities, and methods to ensure patient safety during emergencies. Understanding patient evacuation involves recognizing the need to move patients from unsafe areas to safer locations. Hospitals must consider unique factors like mobility limitations and ongoing treatments. Planning ensures every patient receives the necessary care during emergencies. Evacuation in healthcare facilities presents unique challenges, especially for critical care patients, surgical patients, newborns, and individuals with disabilities. Each group requires specialized planning and coordination to ensure safety and continuity of care. The primary goal of patient evacuation is to protect life while maintaining care continuity. Balancing speed and safety is crucial, and effective planning supports these objectives, ensuring patient well-being throughout the evacuation process. Evacuation decisions should be based on fire conditions, patient risk levels, facility design, and emergency response capabilities. Timely decisions improve outcomes by ensuring the right actions are taken swiftly and effectively. Horizontal evacuation involves moving patients to safer areas on the same floor, minimizing disruption and physical stress. This method is preferred initially as it maintains care continuity and reduces risk. Horizontal evacuation requires less physical effort and keeps patients close to resources. It is supported by facility design and ensures care continuity, making it a practical and effective approach during emergencies. Vertical evacuation involves moving patients to different floors using stairwells and designated routes. It presents challenges like physical strain and coordination demands, requiring careful planning and execution. Vertical evacuation becomes necessary when fire spreads beyond a single compartment. Emergency leaders must assess risks and coordinate movement to ensure safety, requiring precise planning and execution. Ambulatory patients can evacuate with minimal assistance, representing the most mobile segment. Clear instructions and designated staff support ensure safe movement during emergencies. Non-ambulatory patients require assistance through wheelchairs, stretchers, or beds. Prioritizing safety and stability, staff training is essential for effective evacuation of these patients. Critical care patients depend on life support equipment, requiring specialized evacuation plans. Equipment transport, power requirements, and clinical support must be addressed to ensure their safety. Healthcare facilities use specialized equipment like evacuation chairs and stretchers to support safe patient movement. Regular maintenance ensures readiness and reliability during emergencies. Rescue prioritization helps ensure that the most vulnerable individuals receive appropriate assistance. Prioritization should be established before emergencies to guide effective response efforts. Compartmentation and defend-in-place strategies allow patients to remain safely within certain areas while conditions are evaluated. Building design plays a critical role in supporting these strategies. A real-world case study demonstrates successful horizontal evacuation during a hospital fire. Well-designed protocols and trained staff ensured patient safety without requiring full evacuation. Understanding patient evacuation categories helps organizations develop effective plans. Ambulatory patients form the largest group, while critical care and neonatal patients require the most support. Successful evacuations depend on factors like staff training, emergency planning, and communication systems. Consistent training and planning are crucial for patient safety during emergencies. Emerging technologies like real-time location systems and digital patient tracking enhance evacuation coordination. These innovations improve response times and decision-making during emergencies. Patient evacuation and rescue procedures are vital for healthcare fire safety. Planning, training, equipment design, and understanding patient needs are essential for effective evacuation strategies. Healthcare facilities contain diverse operational environments, each with unique fire hazards and safety requirements. Understanding these specialized risks is essential for maintaining safe patient care operations. In this CDC training chapter, learners will explore fire safety considerations within operating rooms, intensive care units, laboratories, pharmacies, imaging departments, outpatient services, and other specialized healthcare environments. Different healthcare departments perform specialized activities involving equipment, chemicals, gases, electrical systems, and patient care technologies. Each operational area presents unique fire hazards that require specific controls and safety protocols. Operating rooms contain ignition sources, oxygen-enriched atmospheres, surgical equipment, and combustible materials. These conditions increase the potential for surgical fires if appropriate precautions are not followed. Surgical fires occur when an ignition source comes into contact with fuel in an oxygen-rich environment. Awareness and prevention measures are essential to protecting patients and staff from these risks. Prevention measures include controlling oxygen concentrations, managing ignition sources, using fire-resistant materials, and conducting pre-procedure safety checks. Team communication plays a critical role in preventing incidents. Intensive care units contain life support equipment, oxygen systems, electrical devices, and highly vulnerable patients. Fire incidents in these areas can have serious consequences due to patient dependency and limited mobility. ICUs often contain numerous electrical devices operating continuously. Regular equipment inspections, preventive maintenance, and electrical load management help reduce fire risks and ensure reliable patient support. Laboratories may contain flammable chemicals, compressed gases, reactive substances, and specialized equipment. Safe handling, storage, and ventilation practices are essential for preventing fire incidents. Laboratory safety requires continuous oversight. Chemical compatibility, proper labeling, storage segregation, and inventory control are important fire prevention measures. Organizations should ensure that flammable substances are managed according to established safety requirements. Pharmacies may store alcohol-based products, chemicals, packaging materials, and electrical equipment. Fire prevention strategies include safe storage practices, housekeeping standards, and equipment inspections. Pharmacy safety supports operational safety. Imaging departments contain sophisticated electrical equipment, cooling systems, and specialized infrastructure. Preventive maintenance and equipment monitoring help reduce operational risks. Technical reliability supports patient care. Outpatient facilities may experience high patient volumes and frequent movement of visitors. Organizations should maintain clear evacuation routes, reliable detection systems, and effective emergency communication procedures. Preparedness improves safety outcomes. Emergency departments operate continuously and may experience unpredictable patient volumes. Fire safety planning should consider crowd management, rapid response capabilities, and uninterrupted patient care requirements. Preparedness supports resilience. Healthcare kitchens contain cooking appliances, grease-producing equipment, and heat sources. Regular cleaning, equipment maintenance, and suppression system inspections reduce fire risks. Kitchen safety supports overall facility protection. Maintenance, renovation, and construction activities can introduce temporary fire hazards. Organizations should implement hot work controls, contractor management procedures, and additional monitoring when high-risk activities occur. These strategies require enhanced oversight. A hospital implemented a comprehensive surgical fire prevention program that included staff training, safety checklists, oxygen management protocols, and enhanced communication procedures. The initiative significantly reduced near-miss incidents and improved compliance with operating room safety requirements. Different healthcare environments contribute varying levels of fire risk. Operating rooms and critical care environments often show increased attention due to their complexity and patient vulnerability. Several expanded fire safety programs combine technical controls, workforce competency, and management oversight. Training and preventive maintenance consistently rank among the most effective controls. Healthcare organizations are increasingly adopting intelligent monitoring systems, predictive maintenance tools, and digital safety management platforms. These technologies help identify risks earlier and support more effective decision-making. Innovation continues improving healthcare fire safety performance. Healthcare operational environments present unique fire hazards that require specialized prevention and protection strategies. Operating rooms, intensive care units, laboratories, pharmacies, imaging departments, clinics, and outpatient services all require targeted risk management approaches. Staff training and competency development are essential components of healthcare fire safety programs. Even the most advanced fire protection systems depend on knowledgeable personnel who can respond effectively during emergencies. In this CCG training chapter, learners will explore fire safety training programs, fire drill planning, emergency exercises, competency assessments, workforce readiness strategies, and simulation-based learning approaches. Training helps employees understand fire risks and identify hazards early before they escalate. Staff learn evacuation methods, alarm protocols, and their specific responsibilities during emergencies. Well-trained staff protect patients and colleagues, strengthening the organization's overall emergency response. Competency refers to the knowledge, skills, and abilities required to perform safely and effectively during fire-related emergencies. Healthcare organizations should establish competency requirements for all relevant staff. Understanding the behavior, prevention strategies, and organizational emergency policies is crucial. Practical ability to operate fire suppression equipment, execute evacuations, and communicate effectively is essential. Employees must also make sound decisions under pressure and coordinate with colleagues during emergencies. Clear objectives help organizations evaluate training effectiveness and ensure programs support both prevention and response activities. Increasing recognition of fire risks and unsafe conditions throughout the facility is vital. Improving capabilities for rapid, coordinated response to fire-related incidents is crucial. Strengthening readiness to safely evacuate patients, visitors, and staff is necessary. Ensuring adherence to organizational fire safety policies and regulatory requirements is essential. Different roles may require different levels of training. Tailored education improves relevance and ensures personnel are prepared for the specific challenges they may face. Foundational fire safety orientation for all staff is crucial. Periodic updates to reinforce knowledge and address changes in procedures or regulations are necessary. Targeted instruction addressing unique, life risks within specialized clinical or operational areas is important. Advanced instruction for personnel with designated emergency roles and responsibilities is essential. Programs that equip managers and supervisors to lead teams effectively during fire emergencies are vital. New employees should receive fire safety orientation before beginning work. Early education establishes expectations and ensures all personnel understand their responsibilities from day one. An overview of the organization's fire response protocols and alarm activation steps is provided. Familiarization with primary and secondary exit paths throughout the facility is essential. Instruction on responding to fire alarm signals and notifications is crucial. Processes for identifying and reporting potential fire hazards are important. Different departments face different fire risks. Specialized training improves preparedness by addressing the unique hazards and operational conditions found in each area of the healthcare facility. High-risk environments with flammable anesthetic agents, surgical drapes, and ignition sources require specialized fire prevention protocols. Chemical storage, open flames, and electrical equipment create unique hazards requiring targeted safety measures. Personnel working with large machinery, power tools, and building infrastructure require advanced fire prevention training. Complex patient evacuations and life support equipment demand specialized instruction and response procedures. Fire drills allow organizations to test emergency procedures and evaluate staff readiness in a controlled, low-risk environment. Practice builds confidence and competence before actual emergencies demand action. Personnel become comfortable with their designated roles before real emergencies demand action. Drills reveal whether established emergency procedures work as intended under realistic conditions. Repeated practice reduces anxiety and improves decision-making speed during actual emergencies. Fire drills evaluate multiple dimensions of emergency preparedness. They also identify weaknesses that may require corrective action, supporting continuous improvement in organizational readiness. Evaluating the effectiveness of alarm notifications and staff-to-staff communication during emergencies is crucial. Testing the speed, orderliness, and completeness of patient or staff evacuations is essential. Observing how personnel prioritize actions and make decisions under pressure is important. Assessing how well departments and teams work together during simulated emergencies is vital. Effective fire drills require careful preparation to ensure they provide meaningful learning opportunities. Planning improves exercise quality and maximizes the value of each drill conducted. Defining specific goals for each drill, such as testing evacuation speed or communication protocols, is essential. Creating scenarios that reflect actual fire risks present within the specific facility environment is crucial. Ensuring all personnel understand the importance of their roles and are expected to participate fully is necessary. Establishing measurable standards for assessing performance during and after the exercise is important. Conducting structured debriefs to capture lessons learned and identify areas for improvement is vital. During drills, participants should follow established procedures as realistically as possible. Exercises provide valuable performance data that informs future training and improvement efforts. Observers should ensure that assigned roles execute exactly as they would during an actual emergency. Designated observers assess communication effectiveness, response times, and protocol compliance. Evaluators note how personnel prioritize actions and adapt when unexpected challenges arise. Performance metrics are recorded to support post-exercise analysis and corrective action planning. Simulation training creates realistic emergency scenarios without exposing personnel to actual danger. Experiential learning enhances retention and builds lasting competency. Employees rehearse critical emergency skills in a safe, controlled environment, creating valuable learning opportunities. Teams practice working together under simulated pressure, strengthening interdepartmental communication and collaboration. Repeated simulation exposure reduces anxiety and improves personnel readiness for real emergency situations. Competency assessments measure employee knowledge, practical skills, and emergency response capabilities. Assessment helps verify readiness and identify personnel who may require additional support. Evaluating theoretical knowledge of fire safety principles, emergency procedures, and organizational policies through structured assessments is crucial. Requiring personnel to physically demonstrate skills such as fire extinguisher operation and evacuation procedures is important. Supervisors and evaluators observe staff performance during drills and daily operations to assess real-world competency. Immersive scenarios test integrated knowledge and skills under realistic emergency conditions in a controlled setting. Learning continues after every exercise. Each drill and assessment is an opportunity to strengthen the organization's fire safety culture and improve future performance. Regular drill and assessment results to identify performance gaps and areas of concern are essential. Developing targeted corrective actions including additional training or procedure revisions is crucial. Executing improvements and updating policies to address identified weaknesses is necessary. Conducting follow-up reviews to verify that corrective actions have achieved the desired outcomes is important. Leaders play an important role in supporting training initiatives, allocating resources, and reinforcing fire safety expectations. Leadership influences organizational culture and sets the tone for employee engagement. Leaders champion training programs and ensure they receive the organizational priority and resources they require. Resources, including time and funding, must be committed to sustain effective training programs. When leaders are involved in and endorse training, employees are more likely to engage seriously and take ownership. Leaders establish and uphold expectations that all personnel fulfill their fire safety training responsibilities. A hospital conducted a fire drill that revealed significant delays in communication and widespread confusion among staff. Post-exercise review documented specific weaknesses, including unclear communication, inconsistent patient evacuation procedures, and identified gaps. Leadership initiated corrective actions, including targeted training, department-specific drills, and documented procedures to address identified gaps. Improved outcomes demonstrated measurably improved response times, clearer communication, and consistent execution of participating departments. Comprehensive fire safety training programs address both prevention and emergency response requirements. Emergency procedures and evacuation preparedness often receive the greatest focus within well-designed programs. The largest component, covering response protocols, alarm activation, and incident command roles. Combined, evacuation and fire prevention awareness form the backbone of any comprehensive program. Familiarity with fire suppression equipment and regular drill participation reinforce training and readiness. Assessments verify that training has achieved the desired outcomes and identify remaining gaps. Preparedness depends on consistent education, practice opportunities, leadership engagement, and performance evaluation. Organizations that invest in workforce development generally achieve stronger emergency response outcomes. Regular training and fire drill participation are the most impactful factors. Leadership support and simulation exercises also contribute significantly. Competency assessments and continuous feedback are essential for achieving and sustaining workforce-wide emergency readiness. Emerging technologies are transforming workforce training programs, providing immersive and flexible learning experiences that were previously impossible. Technology continues expanding training opportunities for healthcare organizations of all sizes. Fully immersive simulated fire emergencies allow personnel to practice response skills in photorealistic environments without any physical risk. Overlay digital emergency information over real-world environments, enabling contextual training within actual facility spaces. Advanced scenario-based platforms allow organizations to design, run, and evaluate complex emergency exercises. On-demand mobile accessible training modules provide flexible, on-demand education that fits into busy healthcare schedules. Staff training, fire drills, and competency development are essential for maintaining effective fire safety programs. Organizations must provide ongoing education, realistic practice opportunities, competency assessments, and continuous improvement initiatives to ensure workforce readiness. As taught in CDGTraining's framework, well-trained personnel are some of the most valuable fire safety resources within any healthcare organization. Fire safety audits, inspections, and compliance activities help healthcare organizations identify deficiencies, verify system performance, and ensure adherence to safety requirements. Learners will explore inspection programs, audit methodologies, compliance monitoring systems, documentation practices, corrective action management, and strategies for maintaining adherence to healthcare fire safety. Fire safety compliance involves meeting applicable regulations, codes, standards, and organizational requirements designed to protect life and property. Effective compliance programs reduce risk exposure and create a culture of safety throughout the organization. Audits evaluate whether fire safety programs are functioning effectively and meeting established requirements across all departments. They help identify gaps, verify implementation of controls, and assess overall performance against defined benchmarks. Both audits and inspections are critical components of a comprehensive fire safety program, but they serve distinct purposes. Inspections focus on physical hazards and equipment condition, while audits assess systems, procedures, and management effectiveness. Healthcare facilities may conduct inspections at varying frequencies depending on regulatory and operational requirements. Regular inspections support early hazard identification and help prevent minor issues from escalating into serious safety deficiencies. Equipment deficiencies should be addressed promptly. Delayed repairs compromise emergency readiness and may result in compliance findings. Regular inspections ensure fire protection equipment is in optimal condition. Facility inspections evaluate a broad range of conditions that may increase fire risk. Routine observation supports prevention and early intervention. Key areas evaluated include housekeeping, exit access, electrical systems, and fire protection system accessibility. Compliance requirements vary by jurisdiction but share common life safety objectives. Understanding applicable standards is essential for every healthcare safety professional. Documentation provides evidence that required activities have been completed. Accurate records support accountability and regulatory compliance, while good documentation improves transparency across the organization. Effective audits begin with thorough planning. Preparation improves audit quality and ensures that assessments deliver meaningful, actionable results. Define objectives, establish scope, set evaluation criteria, and schedule and communicate effectively. Internal audits are performed by qualified personnel within the organization. These reviews provide an opportunity to identify opportunities for improvement before external inspections or accreditation assessments occur. External audits provide objective evaluations of compliance and program effectiveness, offering perspectives that internal teams may not identify on their own. External feedback supports improvement and provides valuable benchmarking against industry standards and best practices. Nonconformities occur when requirements are not met. Identifying them accurately is the foundation of effective corrective action planning. Overdue inspections, blocked exits, and missing documentation are among the most critical nonconformities. Corrective actions address identified deficiencies by eliminating the root cause and restoring compliance. Preventive actions reduce the likelihood of future problems by addressing systemic weaknesses before they result in nonconformities. Performance indicators help organizations track compliance trends and evaluate improvement efforts over time. Measurement supports accountability at all levels of the organization. This case illustrates how targeted management interventions, not just technical fixes, drive lasting compliance improvement. Within 1 year, audit findings decreased significantly and inspection completion rates improved, demonstrating the impact of systematic compliance management. Audits typically evaluate multiple components of the fire safety management system. Fire protection systems and documentation are among the most frequently reviewed areas. Understanding where auditors focus their attention helps organizations prioritize resources and strengthen the areas most likely to generate findings. Incomplete documentation is the leading driver of compliance findings, a reminder that administrative rigor is just as important as physical safety measures. Healthcare organizations increasingly use digital tools to manage inspections, audits, corrective actions, and compliance records. Technology supports efficient compliance management and reduces the administrative burden on safety teams. Fire safety audits, inspections, and compliance activities help healthcare organizations verify performance, identify deficiencies, and strengthen fire protection programs across all levels of the organization. Regular audits, inspections, and compliance monitoring help healthcare organizations identify risks early, maintain accountability, and continuously improve fire safety performance. Every incident, near miss, and safety event provides valuable learning opportunities for healthcare organizations. Effective investigations help identify what happened, why it happened, and how similar incidents can be prevented in the future. In this CDG training chapter, learners will explore incident reporting systems, investigation methodologies, evidence collection techniques, root cause analysis tools, corrective actions, and organizational learning frameworks. Incident investigation is a structured process used to examine safety events and identify contributing factors. The purpose is not to assign blame but to understand causes and improve safety performance. Effective investigations support prevention and learning, building a stronger safety culture over time. Without investigation, organizations may miss opportunities to identify weaknesses in systems, procedures, training programs, or equipment. Investigations help reduce the likelihood of repeated incidents by surfacing root causes and system gaps. Learning from events strengthens organizational resilience and improves long-term safety performance across all departments. Organizations should investigate a wide range of safety events to capture every learning opportunity. Fires, smoke events, equipment failures, oxygen-related incidents, false alarms, and near misses all provide valuable lessons without resulting in harm. Every event can reveal improvement opportunities. Employees identify fires, near misses, hazards, or safety concerns as reportable events. Prompt reporting is the first step in the investigation process. Timely reporting improves information accuracy. Employees should understand when and how to report incidents, hazards, and near misses through established systems. A multidisciplinary approach improves the quality of findings. Diverse perspectives support comprehensive analysis. Safety professionals lead the investigation process and ensure methodology is followed consistently. Facility engineers provide technical expertise on building systems, equipment, and infrastructure. Department managers offer operational context and knowledge of departmental workflows and procedures. Clinical representatives contribute patient care perspectives and clinical environment knowledge. Investigators should preserve the incident scene whenever possible to protect physical evidence. Unauthorized changes may compromise the ability to determine what occurred. Scene control supports accurate investigations. Access should be restricted to authorized personnel only until documentation and evidence collection are complete. Accurate evidence collection supports reliable conclusions and helps investigators reconstruct the sequence of events. Inspect equipment involved in or near the incident for signs of failure, overheating, or misuse. Inspect wiring, connections, panels, and devices for faults or code violations. Review sprinkler activation records, suppression system status, and alarm panel data. Collect all relevant maintenance logs, work orders, and inspection histories. Document temperature, humidity, ventilation, and storage conditions at the time of the event. Witness interviews provide valuable information regarding actions, observations, and conditions present before and during the incident. First-hand accounts often reveal details not captured in documentation. Interviews should be conducted respectfully and objectively. Open communication improves data collection and encourages honest, complete responses from witnesses. Documentation helps identify trends and contributing factors, providing important context that physical evidence alone cannot supply. Work orders, service logs, and equipment maintenance histories reveal inspection gaps or deferred repairs. Training records confirm whether staff received required instruction and when refresher training last occurred. Prior inspection findings may indicate known hazards that were not adequately addressed before the incident. Past incident histories may identify recurring patterns and systemic vulnerabilities across the organization. Root cause analysis, commonly called RCA, is a structured process used to identify the underlying causes of incidents. Rather than focusing only on immediate issues, RCA explores deeper organizational and systemic issues. Understanding root causes supports long-term prevention. Surface-level fixes address symptoms. RCA addresses the conditions that allowed the incident to occur in the first place. Effective RCA transforms individual incidents into organization-wide safety improvements. The 5 whys technique involves repeatedly asking, why, to move beyond surface-level explorations and uncover underlying causes that contributed to the event. Simple methods can produce powerful insights. Ask why the incident occurred. Identify the immediate trigger or failure. Ask why that trigger occurred. Move one level deeper into contributing factors. Continue probing. Identify process or procedural breakdowns. Explore systemic or organizational conditions that enabled the failure. Reach the root cause, the fundamental condition that, if corrected, prevents recurrence. Fishbone diagrams organize potential causes into categories, helping teams visualize complex relationships between contributing factors. Structured analysis improves understanding of multi-causal incidents. By categorizing causes visually, investigation teams can ensure no contributing factor is overlooked and can prioritize corrective actions based on the most impactful categories. Most incidents result from multiple contributing factors rather than a single cause. CDGTraining emphasizes that comprehensive investigations examine both immediate and underlying contributors. Human error, equipment failures, inadequate procedures, insufficient training, environmental conditions, and management system weaknesses all play a role in incidents. Corrective actions should address identified root causes rather than symptomatic alone. Effective actions reduce future risk and create lasting improvements in safety performance. Replace or repair deficient equipment identified as a contributing factor. Address training gaps to address identified knowledge or skill gaps. Update written procedures to reflect lessons learned and best practices. Implement physical safeguards that reduce reliance on human performance alone. Actions may also involve management system enhancements that improve oversight, communication, and accountability across the organization. A hospital experienced a small electrical fire with a medical equipment storage area. The incident triggered an immediate investigation by the facility safety team and engineering department. Overheating electrical connections in the storage area, inadequate inspection frequencies for electrical systems, and delayed maintenance activities due to staffing constraints were identified as contributing factors. Enhanced maintenance schedules for electrical systems, increased frequency of inspections, and staff training on electrical hazard recognition were implemented as corrective actions. The corrective actions resulted in improved fire prevention performance and a stronger culture of proactive maintenance across the facility. Investigations rely on multiple information sources to build a complete understanding of events. Relying on a single source risks missing critical content that only emerges when multiple data streams are considered. A well-rounded investigation draws from all available sources. Physical evidence and employee interviews often provide the most valuable insights. Maintenance, inspection, and training records combined reveal systemic patterns. Root cause analysis often includes a combination of technical, human, and organizational factors. Addressing systemic issues helps organizations create sustainable improvements. Equipment failures and inadequate maintenance top the list, underscoring the critical importance of proactive maintenance programs and regular inspections for healthcare safety management. Lessons learned from investigations should be communicated throughout the organization. Knowledge sharing helps prevent similar incidents in other departments and facilities, multiplying the value of every investigation conducted. Learning culture strengthens safety performance by creating environments where staff feel empowered to report, discuss, and act on safety information without fear of blame. Incident investigation and root cause analysis are essential tools for improving healthcare fire safety performance. Organizations should establish effective reporting systems, conduct thorough investigations, analyze root causes, implement corrective actions, and share lessons learned. As taught in CDGTraining's framework, the goal of every investigation is not simply to understand what happened, but to create safer systems that prevent future incidents and protect patients, staff, visitors, and healthcare operations. Every incident and near miss is an opportunity to learn. Technology is revolutionizing healthcare fire safety with intelligent systems and real-time management. In this chapter, we explore advanced fire detection, predictive maintenance, and digital emergency solutions. Healthcare fire safety has evolved from manual inspections to intelligent digital systems. Each era marks a significant leap in safety capabilities, enhancing decision-making and performance. Advanced detection systems use analytics to identify fire conditions more accurately, supporting efficient healthcare operations and focusing on genuine emergencies. AI in fire safety enhances detection, risk assessment, maintenance, and decision support, improving human capabilities and response times. AI systems analyze data to predict risks, monitor environments, and enable proactive interventions, reducing potential hazards effectively. IoT technologies connect sensors and systems, enhancing visibility and control across healthcare campuses, improving fire safety management. IoT sensors monitor environmental conditions, providing real-time data to strengthen prevention efforts and ensure safety across healthcare facilities. Predictive maintenance uses data to identify equipment issues before failures occur, enhancing reliability and preventing hazards. Digital twins simulate real-world scenarios, aiding in planning and preparedness by allowing exploration of different outcomes. Modern fire alarm systems integrate with various management systems, improving efficiency and reducing response times during emergencies. Digital emergency management platforms enhance coordination, resource tracking, and decision-making during emergencies, supporting effective response. Mobile communication solutions enable rapid distribution of emergency information, improving coordination and response across healthcare facilities. RTLS technologies improve emergency response by tracking personnel, patients, and resources in real time, enhancing evacuation and coordination efforts. Robotic technologies automate inspections and monitoring, enhancing safety by performing repetitive tasks and identifying potential risks. As fire safety systems become more connected, cybersecurity is crucial to protect data and ensure reliable operations. A case study shows how intelligent fire detection and management systems significantly reduce false alarms and improve emergency coordination. Adoption rates of emerging fire safety technologies show significant investment in improving prevention, detection, and response capabilities across the industry. Emerging technologies offer significant benefits, including faster detection, improved risk identification, and enhanced operational efficiency. Organizations face challenges like cost management and cybersecurity but have opportunities for proactive prevention and competitive advantage. Emerging technologies are transforming fire safety by providing better visibility, predictive capabilities, and emergency response support. Long-term fire safety success requires more than compliance and emergency response capabilities. Healthcare organizations must establish governance structures, leadership commitment, workforce engagement, and continuous improvement systems that support sustainable fire safety performance. In this CDGTraining chapter, learners will explore fire safety governance, leadership responsibilities, organizational culture, sustainability strategies, continuous improvement models, professional development pathways, and certification opportunities. A sustainable fire safety program consistently protects patients, staff, visitors, and infrastructure over time. Sustainability requires ongoing investment in people, processes, technology, training, and organizational culture. Strong programs evolve as risks and operational needs change, ensuring continued relevance and effectiveness. Successful fire safety programs are built on interconnected pillars that work together to create long-term organizational resilience. Strong foundations support lasting success. Governance strengthens organizational accountability and ensures fire safety remains a strategic priority. Organizations should establish formal structures that monitor performance, allocate resources, and support decision-making. These structures may include dedicated safety committees, executive sponsors, and cross-functional oversight teams. Leadership sets the tone for organizational safety. Their commitment is the single most influential factor in program success. Leaders are responsible for establishing expectations, promoting safety culture, allocating resources, and supporting compliance initiatives. Visible leadership commitment influences workforce engagement and program effectiveness. Well-documented processes improve consistency and accountability across all departments and facilities. Policies should be reviewed regularly to reflect changes in regulations, operations, and emerging risks. A strong fire safety culture encourages proactive risk management, hazard reporting teamwork, and continuous learning. Culture influences everyday behavior at every level of the organization. Employees play a vital role in sustaining fire safety performance. Engaged employees strengthen organizational resilience and help maintain a culture of safety. Continuous workforce development helps organizations maintain readiness and adapt to changing risks. Competent employees improve safety outcomes and reduce the likelihood of preventable incidents. Organizations should establish key performance indicators to evaluate program effectiveness. Measurement supports continuous improvement and demonstrates accountability to stakeholders. Continuous improvement involves regularly evaluating performance and implementing enhancements. Improvement should become part of daily operations, not a periodic exercise. Fire safety should be integrated into broader organizational risk management activities. This approach ensures that fire risks are considered alongside operational, clinical, financial, and strategic risks, improving overall decision-making quality. Technology supports long-term effectiveness, but must be paired with trained personnel and strong governance to deliver full value. Preparedness supports resilience. Organizations that anticipate change outperform those that only react to it. Healthcare environments continue evolving due to technological advances, regulatory changes, workforce challenges, and emerging risks. Organizations should remain adaptable and continuously review their fire safety strategies. Fire safety excellence is achieved when prevention, preparedness, response, compliance, leadership, and culture operate together effectively. Organizations should strive to move beyond minimum compliance and pursue continual advancement. Excellence requires commitment at every level. A healthcare network experienced recurring compliance issues and inconsistent fire safety performance across multiple facilities. Audit scores were weak, incident rates were high, and safety culture was fragmented across sites. The solution involved centralized governance structures, standardized procedures, digital compliance tracking systems, workforce development programs, and performance monitoring systems. Within 3 years, audit scores significantly improved, incident rates decreased, and safety culture strengthened across the organization. Sustainable programs depend on several interconnected pillars. Leadership, workforce competency, and risk management typically provide the strongest foundation for long-term success. Organizations that consistently perform well in fire safety typically invest heavily in leadership involvement, employee engagement, and ongoing workforce development. These factors help sustain performance over time. Throughout this course, learners have explored a comprehensive range of healthcare fire safety topics. Together, these topics provide a complete foundation for managing fire safety within healthcare environments. Visit CDGTraining.com to enroll, get certified, and take the next step in advancing your healthcare fire safety career. Certified hospital and healthcare fire safety professional courses are entirely online and automated, allowing you to learn at your own convenience. Thank you for completing the Certified Hospital and Healthcare Fire Safety Professional course. We wish you continued success in protecting patients, supporting healthcare resilience, strengthening emergency preparedness, and promoting fire safety excellence across healthcare organizations worldwide.